In this video, we are going to talk about how acids and bases react with each other and what products they produce. And because we know that, we can actually make predictions in what happens. All right, so the first thing we're going to talk about is acids reacting with metals. So when an acid reacts with metals, it will form a salt and make hydrogen gas. So look at our equation. We have hydrochloric acid here. We know it's an acid because of this hydrogen right there. And then magnesium is a metal. And by now in chemistry, we definitely know this is a metal. It is on the left side of the periodic table. So what happens here is a single replacement reaction. Hydrogen and magnesium are going to switch places. So magnesium is going to bond with chlorine and makes magnesium chloride. And then hydrogen is going to be by itself, making hydrogen gas. So simple enough, the magnesium is a +2, chlorine is -1, and that's how we get MgCl2. So let's look at this one. Here we have sulfuric acid plus sodium, and sodium is a metal. So we're going to have these two switch places, and then hydrogen gas will be produced. So we have Na2SO4. Now how do we get that formula? Well, we have to go back to where we learned how to make formulas, and sodium is +1, SO4 is a -2, and you crisscross, and that is how you get Na2SO4. And then hydrogen gas is H2. So write this down in your notes if you need it. If not, you don't need to write this down. If you understand that we're making sodium sulfate and you understand how to crisscross, you don't need to write it down. If you need to be reminded of the crisscross method, then write this down so you have it. Acids react with carbonates and bicarbonates. And when they do this, they will form salt, water, and carbon dioxide gas. So here's an example of this. We have hydrochloric acid and sodium bicarbonate, or baking soda. So what's going to happen? Well, here's what happens. We've got a salt, and our salt is sodium and chlorine, so that's where that comes from. We've got the sodium here and the chlorine right here with the acid. And then we have water, H2O, and our carbon dioxide, CO2. So acids react with carbonates and bicarbonates, and when they do, they form salt, water, and carbon dioxide gas. And this is something that you take for an upset stomach. All right, now we've talked about acid rain some, and we've done some work on acid rain. So what is the effects on acid rain on marble? Marble is mostly calcium carbonate. And so here we've got a statue of George Washington before acid rain, and then what has happened over years and years with acid rain. So you can see the chemical reaction going on, and that's why a lot of times they will redo the statues to fix them up and make them look better. All right, so what's going on? Here's acid rain. And then we have marble, which is calcium carbonate. So let's look at the equation and see what happens. Well, we have calcium sulfite plus water plus carbon dioxide. So that's the chemical reaction that's going on that statue every time the rain comes down that has the acid in it. Calcium sulfite will dissolve in water and it washes right off the statue, and so it starts to disappear. Okay, we're going to talk about acid-base reactions. So we can put an acid and a base together, and what we have there is a neutralization reaction. This is a reaction in which an acid and a base react in an aqueous solution, and it produces a salt and water. So here's an example. We have hydrochloric acid. I know the first one is the acid because of the H in front of it. And we're going to put it with sodium hydroxide. How do I know this is a base? Because of the OH. So hydrochloric acid plus sodium hydroxide produces sodium chloride, which is salt, plus water. So it neutralizes. And here's another example. We also have sulfuric acid with potassium hydroxide. When we put those together, we get potassium sulfate, which is a salt, and water. So these are called neutralization reactions. And this is what we call double replacement reactions. We've talked about the 5 different types of reactions. So here we've got a double replacement reaction. They're switching partners. Acids neutralize bases. So neutralization reactions always produce a salt. A salt is an ionic compound. So when we have a neutralization reaction, a salt is produced and water is produced. And it takes the correct ratio of an acid and base to produce a neutral salt. Bases neutralize acids. Milk of magnesia contains magnesium hydroxide, which neutralizes stomach acid, which is HCl. So the reason you take this is because we have HCl in our stomachs. So if we drink this and it gets in our stomachs, it'll kind of calm the acid down so there won't be so much of it, and it helps you not have an upset stomach. So here's the equation for it. We have hydrochloric acid plus magnesium hydroxide produces magnesium chloride, there's your salt, and then water. Acid-base reactions. So here's a simple formula. Acid plus a base produces salt plus water. So let's look at this one. We have an acid and a base. What's it going to produce? Well, it's going to make a salt and water. So you know the second one is H2O. So that's pretty easy. So you can put plus H2O pretty easily. What's going to happen here is lithium is going to bond with nitrate. So you need to find out what is the charge on nitrate, what is the charge on lithium, and then make that formula. So lithium is a +1, nitrate is -1, so there's one of each, LiNO3, and then plus your water. And a salt is an ionic compound. We have a cation and the anion. Now, when we're doing these reactions with acids and bases, it's important to know where these ions coming from. So the positive ion, the cation, comes from the base. The negative ion, or the anion, comes from the acid. And is formed from a neutralization reaction. So the salt is formed from neutralizing the acid in the base. Some salts are neutral, others are acidic or basic. Okay, let's talk about salt formation. So salt usually comes from a strong acid plus a weak base, or a weak acid plus a strong base. So strong actually refers to the degree of ionization, or how easily we can break the ions apart, not necessarily how strong the solution is. So a strong acid plus a strong base produces a neutral salt. So how do we know if it's strong? So a strong acid plus a strong base produces a neutral salt. Well, we use a chart for that. So of course you can find a chart. This is common strong acids and bases. So strong acids, we've got hydrochloric acid. What's another one? Sulfuric acid is strong. Nitric acid is strong. So these are strong acids. And then over here are strong bases, and pretty much the common ones that we know, sodium hydroxide, strong bases. So of course there's a chart you can always reference. All right, let's talk a little bit more about the salt formation. To see if the resulting salt is acidic or basic, we're going to look at the parents that actually make the salt. So we have an acid and a base coming together, And the one who is stronger is going to be the one that wins. So if you have a stronger acid, then your salt is acidic. If you have a stronger base, then your salt is basic. So let's look at our equation here. We've got hydrochloric acid, our HCl, plus sodium hydroxide. So we need to look at our chart and see, are these weak or strong acids? Well, hydrochloric acid is a strong acid and sodium hydroxide is a strong base. So therefore, our salt is neutral. They kind of cancel each other out. Neither one of them is stronger than the other. All right, so let's look at an example where we do have one that is stronger than the other one. Here we have sulfuric acid, which is a strong acid, and ammonium hydroxide, which is a weak base. So the acid is stronger, which means our salt that's formed, ammonium sulfate, is acidic. And then another example we have here, we have acetic acid, and that is a weak acid, and then potassium hydroxide is a strong base. So our salt is going to be basic. All right, so I don't know if you've heard of this word before, but we have what we call a conjugate base and a conjugate acid. So a conjugate base is the product that comes from the original acid, missing the hydrogen. A conjugate acid is the product formed from the original base, gaining a hydrogen ion. Thus, a conjugate acid-base pair is related by the loss or gain of a single hydrogen ion. So let's look at an example. Usually the products are written as ions to show how it will dissolve in water. So here we have an acid being put into water. So what's going to happen? Well, when this acid is put in water, the ions right here are going to separate. So the H here is going to join water, making H3O plus, and then fluorine is off by itself with a -1, which we can find out on our periodic table if you need help with that. So which one is the acid? HF is the acid, so what does that make the base? Water. So water is just kind of behaving like a base, I guess. Water can do a lot of things. It's not actually basic, but it functions as a base in this reaction. Then which one is the conjugate base? The conjugate base is the fluorine ion right here. And our conjugate acid is the H3O plus ion.